Okay, time to write equations. This time I'm going to give you the point and the slope and a point, and we'll see if we can write an equation given that information. Last time I gave you the slope and the intercept, and we use slope-intercept form, y equals mx plus b, and hopefully you remember what that all means. That's the slope, and that's the intercept, and if we know those two things, we can write an equation. So now we'll show you how to write the equation if you're just given the slope and just one point. So y equals mx plus b, let's say we have point 3,1. And let's say our slope is 3, and that's all the information we have. Well, if it's sloping 3, it goes up 3 over 1, up 3 over 1. And it would also go down 3, back 1. What could I figure out about this equation? Well, I could draw the line through there. Almost there. That's a pretty good line. Now, what would my equation be? Y equals mx plus b. Well, what's my m, my slope? Well, that was given, that was 3. And then what's my intercept? It's not given to us, we'd have to figure that out. And as I drew my points on the graph, I was able to figure out that it crosses here at exactly 1, 2, 3, 4, 5, 6, 7, 8. So negative 8 is my y-intercept. And so I know my equation will now be y equals 3x minus 8. So now if I put 1 into the equation, this point here is 1, negative 5. If I put 1 in my equation, I should get negative 5 if that's the right equation. 3 times 1 is 3, minus 8 is negative 5. So yes, it does work. Okay, so if you've got a graph and you can find out the exact crossing, given your point is your starting point and your slope, we can create our equation that way. Now, we're not always given a graph, and we need to find that algebraically as well, know how to do it that way. So let's say we have this situation where the point is 3, negative 2, and the slope is negative 4, 3. Well, if you're like this guy, you should ask yourself, what do I know and what do I need? Well, if I'm writing an equation, I know a point and the slope, and I need to know the slope and the y-intercept. Well, we already said we know the slope. The slope is negative 4 thirds. Now, how are we going to find the y-intercept? Well, we can do some algebra to figure that out. So, let's take our equation, y equals mx plus b, and let's take a look at what we know and what we need to find. Well, I know in an ordered pair this is an x and this is a y. And I know this is the m because it's the slope. So I have x, y, and m. I just got to find b. So I plug in the parts that I know. Y is negative 2. M is negative 4 thirds. And x is 3. And b, y-intercept, we don't know that yet. So now I've got an equation I need to solve it for b. So negative 4 thirds times 3, that is negative 4. So negative 2 equals negative 4 plus b. Now to get b by itself, I add a 4. And once I add 4, I'm left with b equal to negative 2 plus 4 is 2. Okay, so now I know the y-intercept is 2. So now I can figure out my equation. Y equals negative 4 thirds x, negative 4 thirds is my slope, plus b plus 2. Okay, so why don't you try this one down here. The point is negative 3, negative 11, slope of 1/2. See if you can come up with the equation for that. Pause the video, start it when you're ready. Okay, so to solve this one algebraically, we have the point and the slope. Slope was already given, so we can plug in the x value and the y value into our equation. So y was negative 11, x was negative 3. Gave us our equation. We simplified, negative 3/2 plus b. Add 3/2 to both sides to get negative 9/2 as my b value. Once I know that, I can plug those parts into my equation, and there we go. Okay. Next, let's take a look at equations for horizontal and vertical lines. Okay, so in line A, recall if it goes through point 32 and it has an undefined slope. Remember, undefined are vertical lines. And in this case, we know the x is always the same. The x is always 3. So in that case, if the x is always 3, we say, well, that line, the equation is x equals 3, because x is always equal to 3. Now for line B, similar, but this is a horizontal line. Remember, horizontal lines are slope of 0. And it goes through -4 and -6. The y-coordinate in that one is -6. And it cuts through the y-axis at -6. So that means all the points on that line have a y-coordinate of -6. So we'll say line B, equation for that is y equals -6. Okay, so horizontal and vertical lines, there's something you got to remember. They're a little bit different because they don't all follow that format of y equals mx plus b. For this case, because that one isn't a function. It's undefined slope. X is always 3, the y doesn't matter. In this case, slope of 0, so we could say y equals 0x, and it cuts through the y-intercept at -6. We can simplify it in this manner, y equals -6, because 0 times x is 0, and that's really nothing, right? So those are special lines that we take a look at and learn how to use, write the equations for. All right, take a look at this problem, read through it, and try to solve it on your own, come up with the answers. Okay, so reading through the problem, we found that we needed to find out how many newspapers there are if newspapers are increasing at a constant rate of 11.8 newspapers per year. So we figured out that's your M, your slope, rate of change. And then in 1997, there were 903 Sunday newspapers in circulation. So that gives us an information for a specific point in time. So we have point and slope. I've defined my variables. X is the number of years since 1970, and Y is the number of newspapers in circulation. So we know what we're talking about as I start writing my equation. First thing asks us how many newspapers were in circulation in 1970. So what I did is I took how many there were in 97 and went back in time. So I subtracted 11.8 per year for 27 years to get 584.4 newspapers. So that would be our initial or starting point, because this is the time period that it's going from 1970 to 2000. So that would be my b value, right? My y-intercept. So part B tells us to write an equation as a function of number of years since 1970. So if this is our b value, our initial starting point, and our rate of change is 11.8, that gives us our equation there. So to find out how many there are in 2000, 2000 is 30 years since 1930, so I can plug in 30 for x and into my equation and find out that there should be 938.4 newspapers. Now another way to look at this problem is once we get an equation, we can look at it visually to help us solve the problem. So if we go to our graphing calculator, we can enter that equation into our graphing calculator. Then we can set the parameters using the wrench up here. I changed my x-axis from 0 to 30 so that it is in range because there are 30 years. Step tells what we're going by, so I went by 5s. And my y-axis from 0 to, just go to about 1,000. And step by 100 sounds good. That'll put the graph, and I can see my line. I can zoom out a little bit so that I have know what I'm working with. So on this graph now, I can use my graph to help me find the solution. So if I wanted to find out how many newspapers there were in 2000, I remember 2000 is year 30, so I can go over to year 30, because my x value is the number of years, go to 30, go to my graph and find out what's the value there. At year 30, it's 938.4. Okay. If I wanted to find out, well, when are there 700 newspapers? Well, I could look on the y-axis, number of newspapers, 700. Oh, that was about 9 years. 9 years after 1970 would be 1979. Okay, the other way I can do that is make a table. So I could copy this or convert my equation to a table and take a look on my table. Now if I wanted to find out the number of years, that's my x. Well, if I wanted to find 2000, that's year 30. And enter on my table, it'll give me my y value. Okay, so multiple representations, multiple ways to find the value that we're looking for, but the key thing is we've got to be able to find the connection, the relationship between the values. And that's with the equation. And that's by using slope-intercept form when we're given slope and maybe a point, or even the intercept right away. We can create that equation and use that equation and solve algebraically, graphically, or using a table. Okay, so that's all the time we have today. You'll do some work writing more equations, but hopefully you've got enough practice that you can know the concept. If I have a point in the slope, know that I've got to now work backwards and find the intercept in order to get my equation. All right, see you next time. And check your answer when you're done.